Hi guys, welcome back to Technowizard. So let's start with today's session. So let's see our first question. Okay, so this is our first question, and in the circuit the value of I of x is okay. So basically they have given us a circuit and we need to find out the value of I of x. Okay, so basically here is a dependent source and these two are independent sources. Okay, so we have to apply the KCL at this node A. So KCL states that the sum of incoming current is equal to, so incoming current is equal to outgoing current, right? So this is basically a KCL, outgoing current, right? So from here current is coming, and from here 3 ampere current is coming. So here the current flowing is 3 plus I of x from the KCL. Now we will apply the KVL in the outer loop, because we can't apply the KVL in this loop because we don't know the voltage across the current source, right? So that's why we will apply the KVL in the outer loop. So let's write the KVL equation. Okay, so basically we are starting from here. So the first sign that we encounter or coming is -10. So this is -10, right? So current is entering like this, so this will be positive, so this will be negative. Similarly the current is flowing like this, so this will be positive, this will be negative. So this is -10. Now first sign is plus, so it will be plus 2 into I of x. This will be plus resistance value is 1 into 3 plus I of x, and this will be plus 2 ix is equal to 0. So we can simplify it. This will be -10 plus 2 I of x plus 3 plus ix plus 2 I of x is equal to 0. So this will be 2 to 4 and 5. So 5 ix minus 7 is equal to 0. So I of x is coming as 7 by 5, which will be 1.4 ampere current. So for this question option D is right. So let's see our next question. Okay, so this is our next question. For the circuit shown below, the value of R connected between C and D is such that the equivalent resistance of the circuit, by looking into the circuit through the terminals A and B, is R only. Then the value of R is okay. So we have to calculate the value of R, and it is saying that if we find out the value of R equivalent through the terminal AB, we are getting the value of R equivalent as small r only. So we will simply find out the value of R equivalent. So R equivalent is, so these two will be in series in parallel with 3 ohm, right? And then the overall combination will be in series with 2 ohm. So we can write as, so here R equivalent is equal to, so these two are in connected in series, so in series we simply add the resistance. So this is R plus 2. Now their combination is in parallel with 3 ohm, so it is in parallel with 3 ohm resistance. So then the overall combination is in series. So now we will simplify. So so if the two resistances are connected in parallel, so their R equivalent formula is Ra Rb divided by Ra plus Rb when the two resistances are in parallel. So this formula is for the parallel, right? So similarly, so here they are in parallel, so suppose this is Ra, this is Rb, so we will apply the formula here. So this will be R plus 2 into 3 divided by R plus 2 plus 3 plus 2, right? So we will simplify it as 3R plus 6 divided by R plus 5 plus 2. So we will take the LCM. So here the LCM will be R plus 5, so which will be 3R plus 6 plus 2R plus 10 plus 2. 2 plus 6 plus 2 plus 10 plus 2 plus 6 plus 2 plus 10 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 plus right? So we can simplify it as, so it will be 5r plus 16 is equal to, so this is basically r, right? This they have already given us. Okay, so this is r only because they have already given us the value of r equivalent. So we can write it as r into r plus 5, right? So let's see this equation in the next slide. So this is simply 5r plus 16 is equal to r into r plus 5, right? So this is 5r plus 16 is equal to r square plus 5r. So they both will get cancelled out, so simply r square is coming as 16, right? So from here r is coming as plus and minus 4 ohm, and we know that resistance can't be negative, it means resistance is 4 ohm, right? So see the option. So for this question, option B is correct, right? So let's see next question. Okay, so this is our next question. The voltage developed across the 3 ohm and the 2 ohm resistors shown in the figure are 6 volt and 2 volt respectively with the polarity as marked. What is the power in watt delivered by the 5 volt voltage source? Okay, so basically they have given us the two network, and they have also given the voltage across the 3 ohm and 2 ohm, right? So we know that, suppose this is a resistor, right? And if the current is flowing from here, right, if the current is flowing like this, so this terminal will be considered as positive and this terminal will be considered as negative, to show the fact that a voltage drop is occurring in this direction, right? So it means positive terminal is the terminal through which current enters, right? So this terminal is positive, it means here the current is entering like this, because this is positive terminal. Suppose this is current I1 and this terminal is positive, so this here the current is flowing like this. So suppose this is current I2. Now in the question it is saying that we have to find out the power delivered by the 5 volt voltage source. So here this voltage source is delivering the power, so the current must flow like this, right? So because suppose this is a voltage source, if this is delivering the power, then the current will flow like this. But if the current is flowing in the opposite direction, then it will absorb the power. But in the question it is saying that the power is being delivered by the voltage source, so the current must flow like this. Now we will simply apply the KCL. We know that the sum of incoming current is equal to outgoing current. So suppose this is current I, so here the incoming current is what? Incoming current is I plus, this is also incoming current for the network 2, so current I plus I2 is equal to outgoing current is I1. Now we will simply find out the value of I1. So here I1 is, so here I1 current is, I1 is V by R. So they have given us a voltage of, let's see what's the value of voltage. So voltage is 6 volt and resistance is 3 ohm. Okay, so this will be simply 6 by 3 ohm resistance. So current I1 value is 2 ampere. Similarly we will find the value of I2, which is V by R. Now they have given us a voltage of 2 volt and 2 ohm resistance. Okay, so 2 by 2 is 1 ampere. So the equation, so KCL equation will become, so KCL equation is I, current I plus I2, which is incoming current, that will be equal to outgoing current. Now we have to find out the value of current I2 is simply 1 ampere and I1 is 2, so current I is coming as 1 ampere, right? See this. So this is all, this is the KCL equation which I have already developed, right? Now we have to calculate the power delivered. So power is given as, so power delivered is given as voltage into current. So we have voltage is 5 volt and current is 1 ampere, so 5 watt power is being delivered by the voltage source. So option A is correct. Okay, so let's see next question. So next question is, okay, so this is our next question. in the given circuit the value of the voltage source E is, okay. So basically they have given us a circuit, we need to find out the value of E, right. So here simply we have to apply the KVL, right. So we have to select the loop in which we have to apply the KVL. Suppose if I'm applying the KVL in this loop, then we can't find the value of E because there will be three unknown, V1, E and V2, and we don't know the values of V1 and V2, so we can't find. So we will simply select the loop this, because in this loop only E will be unknown, so we can simply find the value of E, right. So here this is 10 volt, so this 10 volt, so it will be like this. So this terminal will be positive, another terminal is negative which is connected to ground, and this volt is all 0 volt is, this is plus, and other terminal will be negative which is connected to ground. So we have to apply the KVL in this loop, right. So we will write the KVL equation. So we will start from here. The first sign that we are encountering is minus, so it will be minus 10. Next is minus 5, right, minus 5 volts, so this is minus 5. Next we are coming is with minus E, which you have to find out the value of E. Next is minus 1, right, so this is minus 1. Next is 0, so it will be plus 0 is equal to 0, so it will be minus 16 minus E is equal to 0. So the value of E is coming as minus 16 volt. So for this question option A is right. See, so let's see our next question. Okay, so this is our next question. Okay, so in this question, for the circuit shown in the figure, the current I is, okay. So basically they have given us a circuit, we have to find out the value of current I, okay. So here see, we know that these two resistance 2R and 4R, they are connected in parallel, right. So suppose if the two resistances are connected in parallel, so the total voltage across them will remain constant, right. So voltage is equal to I into R from the Ohm's law. So we know that current is equal to V by R. So as the voltage is constant because they are connected in parallel, so current will be inversely proportional to R. So if the resistance value increases, current will become half in proportion. See here, so here through the 4R resistance, current flowing is 1 ohm. Now here the resistance is reduced to half. So if the resistance is reduced to half, the current will become double because voltage has to remain constant. So from here, if this is 1 ampere, so here the current will become double because they are connected in parallel. So this will be 2 ampere. So from here 3 ampere current must come. So this is 3 ampere, right. So and this 4R and this 4R, they both are connected in parallel. Suppose this is A point and this is B point, then this point will also be B point because no voltage drop is there, so they both are connected in parallel. Now here the voltage drop across 4R resistance is, current flowing through 4R is 1 ampere and the resistance is 4R, so here the drop is 4R volt. Similarly we will find the current through this 4R, which will be 1 ampere current, right. I will show with the different pen. So here the current flowing is 1 ampere. So if there is 3 ampere current is flowing like this and here 1 ampere, so simply by the KCL equation we can find here the current is 4 ampere, right. See here also, here through the 2R resistance current is I, but here the resistance value is doubled, so the current will become half. So from here the current flowing is I by 2, right, because the resistance value has doubled, so current will decrease. So here the total current is I plus I by 2, that is 1.5 ampere current, and from here 5.5 ampere current is flowing, okay. So basically we have to find out the value of current I. So I will simply apply the KVL in the outer loop, right. I'm showing the outer loop here. So this is the outer loop, okay. So I'm selecting this loop in which I will I'll be gonna apply the KVL equation, right? So I'll draw this circuit for you so that you can easily understand. So this is 2R resistance, this is 4R, okay? So this is 3R, so and this is another resistance, so I'm gonna join them, okay, right? And there is a voltage source, right? I will only put the values in which we are gonna apply the KVL, right? So this was 2R and it was 3R and it was 4R, right? And through 2R the current flowing is like this, and the value of 2 current is I, and here the current is 4 ampere, right? And here the current is flowing like this, it is 1 ampere. So we are gonna apply the KVL in this loop, right? So current is flowing like this, so this will be positive, this will be negative. Similarly this terminal will be positive, it will be negative, and this will be also positive, this will be negative. So I'm gonna write the KVL equation. So I'm writing from here. So this will be simply, here the first sign we are encountering is minus, so it will be minus, resistance value is 4 into R and current is 1 ampere. Now again minus, resistance value is 3 into R, the current is 4 ampere. Now here the next sign is plus, resistance is 2R into current I is equal to 0. So I will take resistance R common from here, so it will be minus 4, it will be minus 12 plus 2 into I is equal to 0. So here resistance can't be negative, it means this bracket term has to be 0. It means minus 16 plus 2I is equal to 0. It means 2I is equal to 16. So current is coming as 8 ampere. So see the option. So here option D is correct, okay? So let's see our next question. Okay, so this is our next question. In the what is the voltage across the load resistance RL in the below circuit? The value of each resistor connected in the circuit is 10 ohm, okay? So here 3 resistance are there and each resistance value is 10 ohm, they have already given, right? So this is 10 ohm and this resistance is also 10 ohm. So we have to find out the voltage across the load resistance RL. So simply I'm going to apply the nodal. Suppose the voltage at this node is V1, right? So I'm gonna apply the nodal. So in the nodal we have to consider the current in the outgoing direction. So from this node, suppose this current is flowing like this, and I have marked the current in the outgoing direction, right? So now I'm gonna write the nodal equation, right? So current always flows from higher potential to low potential, so this will be V1 minus because the nodal current is coming like this, but this voltage source will deliver the current in this direction, so they are opposing the nodal current. So V1 minus 100 because it is opposing the current, divided by 10 plus V1 by load resistance V1 by 10 plus V1 by R2 is equal to 0. So this will be simply 3V1 minus 100 is equal to 0. It means 3V1 is equal to 100. So V1 value is coming as 100 by 3, which is equal to 33.33 volt. So option B is correct, because V1 is the voltage across the load resistance and we have to find out V1 only, right? So for this question B is correct. Let's see next question. What is the value of I what is the value of I for the below shown circuit if V is equal to 2 volt, right? So in this question they have given here voltage is 2 volt, okay? So this is 2 volt they have already given, so we can find the current through 2 ohm resistance, which will be V by R. So 2 by 2, it means 1 ampere. So here the current flowing is 1 ampere, right? So we can find out the voltage at this node, that is V1. So V1 will be simply current into resistance. So here the current will remain same because they are connected in series, which is 1, and the resistance is in 2 ohm in series with 1 ohm, which will be 3. So here the V1 is coming as 3 volt, right? So if V1 is 3 volt, we can find the current through this 1 ohm, which will be 3 by 1. So here 3 ampere current is flowing, right? So here 1 ampere current is flowing, here 3. So definitely from here 4 ampere current must come, right, by the KCL equation. Similarly we can apply the KCL at this node. Here 2 ampere current is flowing, here 4. So definitely from here 6 ampere current must come. So for this question option C is correct, right? So let's see next question. Okay, so this is our next question. Okay, so it is saying that a triangular pyramid built up of 6 wires whose resistances are shown in the figure is fed from a 1 volt battery at the terminal AB. The current through the branch dB. Okay, so basically they have given us a triangular pyramid which is made up of 6 resistances. Their values are given and we have to find out the current through the branch dB. So the branch dB is 1 ohm, so we have to find out the current through 1 ohm resistances. Okay, so basically see here, so this is forming a star connection, so we have to convert this star into delta, right? So suppose this is a star network, right, and I have to convert. So suppose this value is R1, this resistance value is R2, so this is R3. Now I have to convert this star into delta, right? So suppose this is delta. So now suppose this delta values Ra, Rb and Rc. Now they have given us star connection and I have to find out the value of delta. It means I have to find out the value of Ra. So do remember this formula. If we have to calculate the value of Ra, it will be simply R1 plus R3 plus product of R1 into R3 divided by the branch opposite to Ra is R2, so divided by R2. Similarly RB will be equal to, so RB will be equal to R1 plus R2 plus their product R1 R2 divided by branch opposite to RB is R3, and similarly we can find the value of RC, which will be equal to R2 plus R3 plus R2 R3 divided by branch opposite to RC is R1. Now here this is star connection, so we will find out the value of Ra, Rb and Rc, right? So see, let's see in the next slide. So value of R of A will be equal to, so Ra is here, so this will be 1 plus 1 plus 1 by 2. Okay, so this will be 1 plus 1 plus their product 1 by 2, so it will be simply 2 plus, so Ra value is coming as 2.5, right? So it will be 2.5 ohm. Similarly we can find the value of Rb, which will be equal to 1 plus 2 plus their product 2 by 1, so it is coming as 5 ohm. Similarly the value of Rc is coming as 5 ohm, right? So I will draw the circuit. Okay, so basically I have converted this star into delta. So now our circuit will become like this, right? Because I have converted this star into delta. So I will draw the circuit here. So now already they have given us a delta network like this, right? So its value was 2 ohm, 1 ohm, 1 ohm. Here a 1 volt battery was connected. So this is 1 volt battery. This was positive, negative, this was A terminal, this was B terminal, this was G terminal. Now I have converted this star into delta, which will become like this. So this is RA, this is RB, and this is RC, right? So I have calculated its value. It was 2.5, it was 5, and it was 5. Now these two are in parallel, right? So we will simplify them. So now these two are in parallel, so its value will become R equivalent will be equal to 2 into 2.5 divided by their sum, that is 4.5. so it will be 5 by 9, so this will be 10 by 9. Similarly these two are also in parallel, so it can be reduced to 1 into 5 by 6, so it will be 5 by 6. Similarly these two are in parallel, so it can be reduced to 5 by 6, right? So now our circuit can be reduced to like this. Okay, so here after reducing the circuit it will become 10 by 9, and here two resistances are there, right? It is 1 ohm and it is 5 ohm. Now this was 5 by 6, and here 1 volt battery is there, so it was A terminal, this was B, and this was D. So 1 volt battery is there, current is flowing like this. So basically these two are now in parallel, so we have already solved them. Their value is 5 by 6. Now we will calculate the current flowing in this path. So the current will be simply V by Z or R equivalent. So they are connected in parallel to the 1 volt, so here voltage is 1 volt. Now these two are in series, which will be 10 by 9 plus their simplify as 5 by 6. So we will solve them, so it will be 1 divided by LCM is what, 18. So this will be 20 plus 15. So here the total current which is flowing in this path is 18 upon 35. Now we have to calculate the current through 1 of resistance, which is branch PD. So by applying the current division rule, which states that current through 1 ohm which be equal to total current into the product of opposite branch, which is 5 ohm, divided by sum of both, that is 1 plus 5. So it will be simply 18 by 35 into 5 divided by 6. So it will be 18 into 5 divided by 35 by 6. So it will be 3 by 7. So current through 1 ohm is coming as 3 by 7, 3 by 7 ampere. So see the option, so option C is correct, right? So let's see our next question. Okay, so this is our next question. In this question it is saying that if R1 is equal to R2 is equal to R4 is equal to R, and R3 is equal to 1.1 of R in the bridge circuit shown in the figure, then the reading in the ideal voltmeter connected between the points A and D is. Okay, so here the value of R1 is R, R2 is also R, R4 is also R, and R3 is 1.1 of R. Now we have to find out the voltmeter reading, right? So here voltmeter is connected between A and B. It means we have to calculate VA minus VB. So V of A is nothing but the voltage across the resistance R2, because voltage at A is equal to voltage across the resistance R2 with respect to the ground. Similarly voltage at B is nothing but the voltage across the resistance R3. Now simply by the voltage division rule we can find out the value of V of R2 and V of R3. So voltage Division rule states that suppose there are two resistances connected in series across a voltage V. Suppose this is resistance R1 and this is resistance R2. Now I have to calculate the voltage across resistance R1. So it simply states that, so V of R1 is equal to total voltage V into R1, the resistance across which we have to find out the voltage, divided by sum of both the resistances. Similarly, if I have to calculate V of R2, so it will be equal to total voltage into the resistance across which we have to find out the voltage, which is R2, divided by sum of both the resistance. So here we can find out the value of V of R2. So V of R2 will be equal to total voltage 10 into resistance R2 divided by sum of both. So here V of R2 will be simply, so V of R2 is equal to total voltage, which is 10 volt into resistance R2 divided by R1 plus R2, right? So voltage is 10 volt, R2 is resistance is R, divided by R1 and R2, both are R, right? So it will be R plus R, so it will be 10R divided by 2R, right? So VR2 is coming as 5 volt. Similarly, V of R3 will be equal to total voltage into my R3 divided by R3 plus R4. So voltage is 10 into R3 is 1.1 of R divided by, sorry, this is R4. So R3 is 1.1 of R plus R4 is R. So it will be simply 10 into 1.1 of R divided by 2.1 of R. So this will be simply, so V of R3 is coming as, this is 110 divided by 21, so it will be coming around 5.238 volt. Now we have to find out the voltmeter reading, so which will be simply V of AB is equal to VR2 minus VR3 is equal to 5 minus 5.238. So answer is coming as minus 0.238 volt is the voltmeter reading. So see the option. So option C is correct, right? So for this question, C option is correct. Let's see next question. Okay, so this is our next question. In the given circuit, if the current through the resistor R is 0, what is the value of current I? Okay, so basically here the current through resistor R is 0. So if this is 0 current, so here 0 current is coming, and from here I current is coming. So here will be, so in this direction current flowing is I plus 0, which will be simply I. Now from here also current I is coming. So here some current, suppose I1 current is flowing in this direction, then by the KCL, if from here I current is coming and I1 has gone this side, so from here I minus I1 current will flow. Now from here 0 current is flowing, it means the entire current I minus I1 will flow in this direction, right? So we have obtained the value of current in each branch. Now we have to find out the value of current I. So we will simply apply the KVL. So we will apply the KVL in this loop and in the outer loop like this. We will not apply the KVL in this loop because we don't know the voltage across the current source, so we can't apply the KVL in this loop. So we have selected these two loops. Now I will mark the polarities. So here current is flowing like this, so this terminal will be positive, this will be negative, right? So now the current is flowing like this, so current is entering, so this terminal will be positive, this will be negative terminal, right? So this is positive. Now voltage polarity is already marked. Now in this 2 ohm resistance current is coming like this, so this is plus and this is minus. Now first of all I will write the KVL equation in this loop, right? So applying the KVL in the first loop, so it will be simply, so I'm starting from here, so this is 2 ohm resistance, and current flowing is I minus I1. So this is I minus I1. Now this again plus sign is coming, so plus 2 into current is I minus I1, and now plus 16, so plus 16 is equal to 0. So it will be simply 4 into I minus 4I1 plus 16 is equal to 0. So it can be written as I minus I1 plus 4 is equal to 0. It means I minus I1 is equal to minus 4. This is equation 1. So next apply the KVL in the outer loop, which will be equal to 2I. So it will be 2I plus 2 into I minus I1, and here the current is 0, so it will be simply 0 volt, right? So after applying the KVL, it will be 2 into I plus 2 into I minus I1 plus 0 is equal to 0. So it will be simply 4I minus 2I1 is equal to 0. It means 2I1 is equal to 4I. So I1 value is coming as 2I. So this is equation 2. Putting in equation 1, so putting in equation 1, so we will substitute the value of I1 here. So it will be, I minus I1 is equal to minus 4. This was equation 1, right? So now I will substitute here the value of I1. So it will be I minus 2I is equal to minus 4. So minus I is coming minus 4. It means current I is coming as 4 ampere. So see the option. So here the correct option is option D, which is 4 ampere, right? So let's see next question. Okay, so this is our next question. In the circuit shown below, the current through RL is, so basically this is RL, which is 30 ohm. Now we have to calculate the current value, right? So simply we can find out the value of current using the nodal analysis, right? So this is a node, and suppose here the voltage is V1 at this node, right? So in the nodal we have to mark the current in the outgoing direction. So suppose this is the current direction, right? So here the current will come like this, but this voltage source is gonna deliver the current in this direction, which is going to oppose this current. So when we will write the nodal equation, it will be like V1 minus because this 220 volt is opposing the nodal current, because it will deliver the current in this direction which is opposing, so it will be minus 220. Similarly this 200 volt is also gonna oppose this current, so it will be minus 200 divided by 120 plus, similarly V1 minus this 200 is gonna similarly oppose minus 220 divided by 60 plus V1 upon 30 is equal to 0. So we're gonna simply take the LCM, will be 120, so it will be V1 minus, so it will be 420 plus, so it will be 2V1 minus 2 into 420, and it will be 4V1 is equal to 0. So it will be 4 to 6 7, 7V1 minus 420 minus 840 is equal to 0. It means 7V1 is equal to 420 plus 840. So 7V1 is coming as 0 6. So V1 value is coming as 180 volt. Now we have to find out the current through RL, which will be simply V1 by RL, which will be equal to 180, and resistance value is 30 ohm. See here, so here RL value is 30 ohm. Now we have to find out the value of IL. So IL is simply V1 by RL, right? So which will be simply 6 ampere. So option B, A is correct, right? 6 ampere. So let's see our next question. Okay, so this is our next question. In the circuit, the voltage across 3 ohm resistance is, okay, so we have to find out the voltage across 3 ohm resistance. Okay, so let's apply the KCL at this node. Here incoming current is I and the outgoing current is I by 3 and I by 3, and suppose in this branch current X is flowing, so simply we will apply the KCL, right? So incoming current is I, which is equal to outgoing current is I by 3 plus I by 3 plus current X. So we have to find out the value of X current, which will be equal to I minus, so it will be 2I by 3, right? So this X current will be equal to I minus 2I by 3, so it will be simply I by 3 current, right? So now I will be applying the KVL in this loop, right? Because we can't apply the KVL in this loop because the voltage across the current source is unknown, right? So we will apply the KVL in this loop. So it will be simply, so first polarity or the sign is negative, so it will be minus 3 minus 3 minus 3. So current is flowing like this, so this will be positive, this will be negative, similarly this will be plus, this will be minus. So plus 2 into current is what, I, plus 3 into current through 3 ohm is I by 3 is equal to 0, so it will be minus 9 plus 2I plus 3I by 3 is equal to 0. So taking the LCM 3, it will be minus 27 plus 6I plus 3I is equal to 0. It means 9I minus 27 is equal to 0. So current value is coming as 27 by 9, which is 3 ampere, right? So here the value of, we have to find out the value voltage across 3 ohm, right? So current through 3 ohm resistance is X. So X is simply I by 3, which is 1 ampere. So voltage drop across 3 ohm is equal to resistance value 3, current is 1 ampere, so it is coming as 3 volt. So option B is correct. Okay, so yeah, that's it for today's session. See you in the next lecture. Till then, bye.